Welcome back to Calculus 1. This is your exam 2 review. As predicted, question number 1. State the definition of the derivative. I want you to state it like this. F prime of x is the limit as h goes to 0 of f of x plus h minus f of x all over h. Question number 2 says, use the definition to calculate the derivative of the following function. The square root of 3x plus 5. We have f prime of x is the limit as h goes to 0, the square root of 3 times the quantity x plus h plus 5 minus the square root of 3x plus 5 all over h. Now, this is one of those where we rationalize the numerator by multiplying numerator and denominator by the conjugate of the numerator. So we multiply by the square root of 3 times the quantity x plus h plus 5 plus the square root of 3x plus 5 over the exact same thing. We have to multiply by something that's equivalent to 1, or else we change the value of the expression and then it's no longer equal. So now, when we FOIL this out, we'll have the limit, begin the next line with equals and then limit as h goes to 0, 3 times the quantity x plus h plus 5, the square roots will go away here. The outer and the inners, when we FOIL this, will cancel, leaving only the lasts, and that's minus the quantity, 3x plus 5, all over h times the quantity, square root, 3 times the quantity x plus h plus 5, plus the square root of 3x plus 5. Now, terms cancel. The 5's will cancel. By the way, the parentheses on the second part in the numerator are essential. We subtract not just the first term, but the entire expression. This h will cancel with 3x over here. This 3x will cancel with the 3x over here in the second grouping. That leaves only 3h in the numerator. We left this h out because we knew it had to cancel. Now, in the limit, as h goes to 0, this gives us then 3 over twice the square root of 3x plus 5. On this last problem, students will sometimes calculate the derivative using the rules of derivatives that we've trained you, the power rule, the chain rule, etc. You will receive no credit for calculating the derivative in that way. Sometimes students write that derivative using the rules of differentiation only because they can't remember how to calculate the derivative using the definition. This is a form of error. There's a man named James Reason who created a classification of error based upon intention. So for instance, if you make an error where you intend to do the right thing, but somehow on execution you goof it up, then that's called a slip. So for instance, if the airline pilot intended to lower the landing gear but instead turned off the landing lights, an error on execution, he knows what he's doing, he knows the right thing to do, he makes an error on execution, that's a slip. A lapse is an error where you know the right thing to do, but through carelessness or inattention, you don't. So for instance, let's suppose that you're the airline pilot again. You know to lower the landing gear, but through carelessness or inattention, you did not. You can see a lapse can have severe consequences. A mistake, on the other hand, is an error based on a misconception. There's something wrong with the concepts in your head, where you intended to do what you did, but what you intended to do was wrong. That's a mistake. Then there is the violation, where you know that what you're doing is wrong, but you do it anyway. Now, to James Reason's classification, I've added one, and that's called the blank. That's where you have no idea. And we see this all the time as math professors, where students leave something blank because they have no idea. So, for a long time, I thought that math students couldn't make a violation. There's just no way they would purposefully do the wrong thing. But I was wrong. There are students who maybe can write down conceptually what the derivative means, but have trouble with the procedural part. And not knowing what to do, they will write down something they do know, trying to demonstrate that they're not completely ignorant, that they know how to do something. That doesn't give them any points. But they're purposefully doing the wrong thing, just not with any malicious purpose, but just trying to demonstrate that they're not completely vacuous. Problem 3 contains a large number of problems where you're asked to calculate the derivative of the given function. So on 3a, for instance, we have f of x equals 5x squared plus 2x plus 1. We ought to give you 2 points for getting the correct answer and minus 2 million points for getting the wrong answer. You'd better get this one right. The derivative is 10x plus 2. On 3b, we have f of x equals the cube root of x plus 1 times the square root of 2x minus 1. Before attempting to calculate the derivative, you should convert the radicals into rational exponents. So I'm going to write equals x plus 1 to the 1/3 times the quantity 2x minus 1 to the 1/2. Now, you can see that we have to apply the product rule, the chain rule, power rule. You should know the rules that you're applying and their names. F prime of x is derivative of the first, that's 1/3, x plus 1 to the negative 2/3, times the derivative of the inside, which in this case is 1, times 2x minus 1 to the 1/2, plus x plus 1 to the 1/3 times 1/2 times the quantity 2x minus 1 to the minus 1/2 times the derivative of the inside, and that is 2. On the exam, please drop it here, box it, you're done. Do not simplify. On part C, f of x is 2x plus 3 over x squared minus 1. name the rules. Here we need to implement the quotient rule and the power rule. F prime of x is the derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. Drop it here. That's it. Do not simplify. I'll assume that you know the algebra necessary to simplify these. I'm testing you over the calculus. On part D, f of x is 1/2 times the quantity, 2 plus cosine cubed of 4x to the power 5. Name the rules. We have multiple applications of the chain rule and a couple applications of the power rule. We have f prime of x equals, bring the power down, leave the inside alone. We deal with that later. Subtract 1 from the exponent. Now, when taking the derivative of the inside, the derivative of 2 is of course 0. The next thing that needs to be addressed is the cube. So we're going to have 3 times cosine squared of 4x. But then we have to multiply by what is being cubed. We need to multiply by the derivative of cosine of 4x. That's going to be minus sine of 4x, and then times the derivative of 4x, which is 4. Box it. Don't simplify. You're done. On part E, we have the function x to the power pi. This is a variable x to a constant power. For these, we use the power rule. Bring the power down and then subtract 1 from the exponent. On problem F, we phrase the problem the other way around. Pi to the variable power x. This is no longer a power function like this. We don't use the power rule for derivatives. Instead, this is an exponential function. Notice how on the next line I'm writing f prime of x equals. Don't write just equals. What you're writing next is not equal to what is above. The natural log of pi times pi to the x. On problem 4, I ask you to make a table showing the derivative of each of the 6 trigonometric functions. I want you to construct the table as I'm about to show you. Some students in past exams have tried to make little shortcuts, and they end up making false statements. Don't be cheap with me. Write out everything as I'm about to write it. Math professors usually frown on their students making false statements. After all, truth is the core value of mathematics. In the table, we have the derivative of sine of x equals cosine x. To the right of that, I'll do the derivative of the cofunctions. The derivative of cosine of x equals minus sine of x. The derivative of tangent of x equals secant squared of x, while the derivative of cotangent of x is minus cosecant squared x. The derivative of secant of x is secant of x tangent of x, while the derivative of cosecant of x is minus cosecant x cotangent x. The table should look something like this. Problem 5 has 3 parts. In 5a, I ask you to calculate the derivative of the inverse tangent. Now, that's the one. That's the one I asked you to remember. You're asked to calculate the derivative of arcsine of x. That's the other one. The other one I asked you to remember. And part C, the function that I give you is x e to the x squared plus the natural log of x. On the first term, there are 2 terms. Remember, terms are separated by plus or minus. On the first term, we have 2 factors, so we need to apply the product rule. The derivative of the first times the second plus the first times the derivative of the second. The derivative of e to the x squared requires the chain rule. The derivative of e to the stuff is e to the stuff, but then you have to multiply by the derivative of that inside stuff, 2x. The derivative of natural log of x is simply 1 over x. No simplification required. On problem 6, I ask you to find the equation of the tangent line to the following relation at the point root 3 over 2 1/2. I'm asking you to find the equation for the tangent line, which means you need a point and you need a slope. The only thing missing is the slope. This is, of course, a circle of radius 1. Taking the derivative implicitly, we get the derivative of x squared is 2x, and the derivative of y squared with respect to x is 2y dy dx. And that, of course, equals the derivative of 1, which is 0. If we multiply through by 1/2, we can cancel the 2's. We'll move the x over and then divide the y off. We'll have y prime is minus x divided by y. The slope that we seek is the derivative evaluated at the point in question. That's going to be minus root 3 over 2 divided by 1/2. The 2's, of course, cancel, and the slope that we seek is minus the square root of 3. The equation for the line, then, is y minus 1/2 equals minus root 3 times the quantity x minus root 3 over 2. The point-slope form of a line. On problem 7, I ask you to calculate several derivatives. For 7a, I give you y is the quantity sine x over 1 plus cosine x all to the power 2. We will have to use the power rule and the chain rule and the quotient rule. 3 rules on 1 problem. You can see what I'm doing now. I'm mixing and matching the rules of differentiation in 1 problem so that you have to do multiple things at once. We'll bring the power down, leave the inside alone, and subtract 1 from the exponent. Then we need to multiply by the derivative of the inside, implementing the chain rule. The derivative of the inside requires that we use the quotient rule. The derivative of the top times the bottom minus the top times the derivative of the bottom, and the derivative of the bottom, the derivative of 1 is 0. The derivative of cosine is minus sine all over bottom squared. Drop it at this point, you're done. On part B, we have x plus sine of y equals x times y. This looks like an implicit differentiation problem. The derivative of x is 1. The derivative of sine y with respect to x is going to be derivative of the outside, leave the inside alone, multiply by the derivative of the inside. On the right-hand side, we have the product of two functions of x. Derivative of the first times the second plus the first times the derivative of the second. At this point, we need to get everything involving a y prime on one side and everything else on the other. When we bring the xy prime over to the left, we can then factor a y prime out. We'll have the cosine of y minus x, and then we get y minus 1. Finally, solving for y prime, we'll have y minus 1 over the cosine of y minus x. On these problems, not only do you take the derivative, you must then solve for y prime. On problem C, we have x squared y cubed plus 2xy plus y squared equals 6. The derivative of the first term requires the product rule and the power rule, and on the second factor, the chain rule. We'll have 2x y cubed, derivative of the first times the second, plus the first times the derivative of the second. Don't forget the y prime. In the second term, we have the product rule again. Derivative of the first times the second plus the first times the derivative of the second. And then the chain rule, 2y times y prime equals 0. The terms that have a y prime will stay on the left. Everything else will be shifted to the right. We'll factor the y prime out. We get y prime times the quantity 3x squared y squared plus 2x plus 2y. That will equal negative 2xy cubed minus 2y. We just divide this factor off, and we get y prime equals negative 2xy cubed minus 2y divided by 3x squared y squared plus 2x plus 2y. Drop it. You're done. On problem 8, I ask you to determine the x values where the function whose graph is given below is continuous and the x values where it is differentiable. Keep in mind there are two parts to this problem, and I'll have to give you some kind of graph. Let's suppose the graph looks something like this. Here at -7, we'll have a cusp. And let's suppose that at -2, we have a vertical asymptote. Function is going to be defined there. And then here at 3, we'll have a jump discontinuity with the point displaced in the middle. And then the function will tend towards the x-axis asymptotically. Where is this function continuous? Well, it's continuous from -infinity until -2. It can't be continuous at 2. We get a one-sided limit. The right-sided limit exists. The left-sided limit does not. So at 3, we get a different limit on each side, so it's not continuous at 3, but it is continuous everywhere in between. and after 3, it's continuous. Where is it differentiable? The function fails to be differentiable at the places it fails to be continuous, but it also fails to be differentiable at -7, where there is no well-defined tangent line, only that cusp. So from -infinity to -7, union. 7 to -2, union. -2 to 3, union. 3 to infinity. On problem 9, I tell you that a 13-foot ladder is leaning against a home. The bottom of the ladder is being moved out at 1 foot per second. The top remains in contact with the wall. It's going to slide down. How fast is the top of the ladder moving when the bottom is 12 feet from the wall? Remember, we have a Pythagorean triple, 5, 12, 13. So when the bottom of the ladder is 12 feet from the wall, the top will still be 5 feet up the wall. We're using the Pythagorean theorem to figure out this value. Now, we have to label the things that are variable, the things that change. The ladder is stuck at 13 feet, but the x and y values will change. And they are related by the Pythagorean theorem by the equation x squared plus y squared equals 13 squared, which is 169. To relate the rates, this is a related rate problem, we have 2x dx dt. The derivative must be with respect to time. X is a function of time, y is a function of time. The derivative of y squared then will be 2y dy dt, and that of course equals 0. You can multiply through by a half to eliminate the 2's. X is going to be 12. Dx dt is 1 foot per second, and y is going to be 5. We move the 12 over and divide the 5 off, so that dy dt is minus 12 over 5. And now the 10th and last problem. I tell you that a man 6 feet tall is 12 feet from a lamp, and the lamp is 18 feet tall. The man is walking at night at 3 miles per hour. How fast is the shadow, the tip of the shadow, moving relative to the lamp? Not relative to the man, relative to the lamp. So we need to define our variables. This 12 feet is actually a variable. We'll define this to be little x. Since the shadow is moving relative to the lamp, we'll define big X to be the distance from the tip of the shadow to the lamp. We have similar triangles. So, turns out big X divided by 18 will be big X minus little x divided by 6. If we multiply both sides by 18, 6 goes into 18 3 times. We'll distribute to get 3 times big X minus 3 times little x. We'll move the big X's together and the little x's by themselves. 3 times little x equals, when we subtract, we get 3 big X minus a big X, that gives us 2 big X. Which means then that 3 times dx dt equals 2 times d big X dt. We've assumed that d little x dt, the rate at which the person is moving towards the lamp, is 3 miles per hour. So 3 times 3 is 9. divided by 2. The big X dt, the rate at which the shadow is moving relative to the lamp, is 9/2 miles per hour, or 4.5.